Hey everyone, welcome back to the REST API in-depth series. In this video, we're going to go over the delete type of request when it comes to REST APIs together. This is actually the final major type of CRUD operation we're going to be going through. We already went through things like the GET requests, POST requests, PUT and PATCH requests. This delete type of request really kind of completes this cycle of the idea of creating a resource, updating that resource, getting that resource, and finally kind of disposing of getting rid of that resource or deleting that resource. So once we kind of go through this final major type of HTTP request type and method, we'll really have a really good understanding of this entire cycle of what it means to have a REST API. And really the core of these CRUD operations, it with the D being the delete here, is going to be mostly done. The rest of the stuff that we have in this series are things like cores and authentication and kind of securing our API and some other things like that along with the project. But really the core part of the actual API, the REST part of the API that we're working with the different verbs and the CRUD operations is going to be ending with this delete type of request. So this should be a little bit easier if you've already kind of gone through all the previous videos when it comes to POST requests, PUT requests, PATCH requests, and GET requests. And this should become much easier to understand. So I highly recommend you take a look at those ones if you're not familiar with those already. But let's just take a look together how this delete request works so we can kind of finish off this cycle. Okay, so to start, I just want to go over, again, as an overview, kind of what this idea of a delete request is. It's one of the HTTP methods or the HTTP verbs. So we saw things, as I mentioned, get, put, patch, and post, and now we're looking at delete. There are other ones actually, for example, in the next video where we're going to be looking at this idea of CORS, cross-origin resource sharing, which is an issue that comes up for security within the browser that kind of catches a lot of people off guard when they're working with the web. We're actually be looking at another type of request type, which is the options type. And there are other ones that are pretty useful, like the head type as well. But really, when it comes to the CRUD operations, this is the final one we need to be looking at. Now, delete, as the name kind of implies, is the idea that we want to delete an existing resource. It's totally shocking, right? So this is the D in the CRUD operations. Create, read, update, finally delete is the D. Now, the delete request may or may not have a request body. It really depends on how you kind of approach the API design. Similar thing we mentioned when we looked at the put and patch requests. You can optionally kind of have the body in there. Oh, actually, for put and patch, you really do need the body in there, but we can optionally have the ID in the body, which is one of the things we looked at in the exercises previously. Now, for delete requests, it's even less needed to have the body, and we'll see kind of how that works and how we kind of get around this fact of even needing the body in the first place, but how we might actually include that if we want to. Now, when we're talking about delete requests, we're going to be sending a delete request, for example, using like the fetch API or some kind of HTTP client or any kind of app will be sending out specifically a delete request to a specific URL endpoint. And I'll show you what that looks like in a second, but this is really kind of the overview of the delete request in general. So again, keep it in context of these operations here that I have on the right hand side. As I've mentioned repeatedly throughout this series, get, post, put, patch, and finally delete is what we're looking at right now. So try to hammer those in so you're really comfortable with these CRUD operations and kind of what those verbs actually entail when it comes to a REST API. Now, I want to show you a bit of a visual for this one. Again, this is kind of a mishmash of the visuals that we saw for things like GET requests, as well as the ones that did have bodies like post and put and patch. So our client here on the left-hand side, it's going to be, us in this case, using something like Insomnia or maybe the browser or an app. We're going to be sending a delete request, and we're going to be asking kind of the question, can you please delete the user with like this identifier? So for example, maybe with an ID of number 5. Right? So imagine that users have different IDs, which are just numbers in this case. We would just say, can you please, server, delete the user with the ID of 5? The server would pick up that request, and it would return back to us, if that was successful, either a 200 status code or a 204. So 200, it means it was okay. Usually there's a body associated with the 200 status codes. So the 204 is really kind of the alternative to that, which is also successful, but there's no body, there's no content, which is what the 204 stands for. Doesn't really matter too much. Just be aware that you will see different APIs use different kind of return status codes, depending on kind of whether they return a body or not, or depending on what the developers felt like, I guess. You'll see a bit of both. Now, there are some considerations here that we do need to take into account. You might be thinking, this sounds kind of sketchy, kind of dangerous, like I can just delete random stuff. And yes, that is a bit sketchy. We do want to have some considerations when it comes to these delete requests, but I'll go to that towards the end of the video once we actually understand how this works behind the scenes. Now, here is kind of how that would work in practice. You can imagine that we have a resource identified, for example, in this case, at a user route. And then the route for that might be like user/ID, for example, in this case. And we would be listening for the delete method specifically for that route. Okay, so in this case, a user route where each user has an ID, and we would be listening for a delete request. Now, again, as I mentioned, the request body is optional because as we saw with like put and patch, for example, we can kind of shove the ID over here in the actual URL. So it's already kind of very apparent just by reading this. If you think about it, if I just gave you these 2 bits of information and you're the server and you only had that information, you didn't have any body, you didn't have anything else, you could probably surmise as to what it is the intention of the client is. The client is saying, okay, delete. Well, what is it that you want to delete? Well, it's going to be this resource right here, in this case named user, and it's got an identifier of 5, whatever that means, in this case probably user ID. So it's the intent is to delete this user of ID 5 from our system or from our database. So that's kind of what we're asking. And again, we can get back either 200 OK or 204 no content, depending usually on if there's a body or not, or kind of what we feel like. So let's go ahead and take a look at what this actually looks like in code, just so we can kind of really hammer that down and get a good kind of a hands-on feeling of what that looks like. And then we'll go over some considerations together. So if I go over to VS Code over here, I'm just gonna create a new file here. I'll just call this delete.ts. I'm also going to create a Deno workspace here by doing Control-Shift-P or Command-Shift-P. I'll type Deno and I have the Deno extension, so I can do Deno enable here, and that'll just nicely create this VS Code folder with the settings.json for Deno for us, so we get the nice autocomplete and all the other fun stuff that comes with it. Looks like I have an upgrade for Deno, but I'll get to that later, so it doesn't matter too much right now. So in here, I'll just create my async function handler, and I'll call this request REQ of type request, and I'm going to return a new response. And in this response for now, just as a default kind of fallback for everything, I'll put a status 404 with no content in there. And then I'll do deno.serve of this handler. And that's going to serve it at the default 8000 port at our local host. So if I save that, and I open my terminal over here, I am going to add a bunch of flags here just so that we can actually read a file and write to a file. So just be aware of that. I'm just going to do that kind of preemptively so we don't have to keep running this command over and over again. We can kind of focus on the code, but we've seen this before. I'm going to make sure I'm in the correct folder here, and I am. I'm going to run deno run --watch not 3 allow net for the networking, and then --allow read for reading files, --allow write for writing files, and then the delete.ts is the file name that we want to execute, in this case our server. So that's going to start a watcher process on port 8000. I'm just going to copy that, and I'm going to paste it into my Insomnia, which I already have open over here. I'll create a new HTTP request, and I'll make sure to change this to the delete type request here. So notice that this is all the HTTP kind of verbs that we're going to be using, and we've already seen a bunch of these already. Notice I mentioned options and header over there as well, which we'll take a brief look at when we come to the cores in the next video. So a delete request, if I send this off, I should get back a 404, which I do, because that's just kind of what our server is doing right now. And now we can actually write our code. So if I come back to my VS Code, I'll just close off my terminal so we have a bit more space here. I'm going to create a new file. I'll just call this users.json. We'll kind of go with the users theme since it's a pretty common one. In here, I'll create an array, and then I'll create an object. And inside of that object, I'll give it an ID. I'll give this one an ID of 1, and for now it doesn't really matter what else we do. We'll just give it a name. Let's just say user number 1 is monkey, and I'll create another user here just so that we have a bit more information. User number 2, ID here, number 2, and we'll say name. And the name for user number 2, let's just say, I don't know, banana. Why not? That's a cool name. That'd be a fun name to have, I guess. We'll just have monkey and banana as our 2 users here, ID 1 and 2. Okay, so notice this is a JSON file. So everything is valid JSON here. So the key names or the property names are in double quotes. We do have integers here for our number values, in this case 1 and 2, but then our strings are also double quotes as well, and this is all inside an array. So we have 2 items inside this array where each item is an object with 2 properties, an ID and a name property. Okay, now if we come back here, I'm going to start kind of just doing the plumbing of this, the general stuff that we normally do. So I'll say const URL is equal to a new URL, so I can grab the requests URL object, so I can split it up into its requisite parts for that URL, things like the path name and the origin and the host and whatnot. Then in here, I can also create my router because I want to route to /users. So I'll say const delete user route is equal to a new URL pattern. And in this case, I want to give it a path name of /user/ and then I'll just do maybe like user ID, just like that. Okay. Now you can really name this whatever you want. I'll just go with that and we can see kind of how that works. Just because I guess actually it makes probably more sense just to say ID in this case. So I'll just go with user/ID because it's already implied that this is the user route. Okay, now we want to say if the delete user route is the one that we're actually hitting right now from our client. So if we're testing it against the URL, if that matches, and the request method, we saw this previously with the get, put, patch, and post operations, but this one's going to be the delete operation. So if it's equal to delete, which is this one right here that we just saw, right? So this is the delete operation method. So if that's what we have, then we want to delete a user. Now, what is the user that we want to delete? Well, we're going to grab that from the client. And in this case, if you think about it, what we're going to be saying is, can you please delete a user with this specific ID, but inside the route? We saw with put and patch, I'm just going to repeat this again because it's really important, that we could provide this in the body if we wanted to, or we could just provide it in the URL. We did it with both, I believe, in the examples. But it really is kind of a design kind of thing, as long as you document it and your users know what to expect and what we should put in the URL versus what we should put in the body, and it's consistent. That's the only thing that really matters. I think the spec advises to put it in the URL, especially for put and patch. But suffice to say, we're going to go with the URL route just to keep it simple, because it doesn't really make sense if you think about it when all the information that we need in this case is inside of the URL with the delete method type. It just kind of makes sense. I just need this. I don't really need more information. I don't have to go through the body to grab an ID. You can just simply just send a delete to that route, with some exceptions, which I'll mention shortly, where that might make some sense. Now, I'll come back in here. We're going to grab that, but this time from the URL. So we're not going to grab it from like the request.json because there's no body. We don't have any body inside the request. We never went here. So I'm going to do this. I'm going to say /localhost/8000/user, and then I want to delete, for example, user number 2, which is banana. Okay. There's no body. The body is empty. We're going to leave it empty. We're just going to send this off to this URL right here, and we're going to expect a response where we can actually get back a 200 or a 204 just for sending this delete request to user/2. So we need to grab this 2 because that's the ID that we're going to be looking for inside our user database. So how do we do that? A few ways to do that. We can kind of split the path name manually. The URL pattern API kind of allows us a nice way to actually get this kind of a bit more elegantly, I guess. So let's go ahead and do that. So I'll say const user ID is equal to we'll say once we have once we're in here, we know that we are already matching against /user/ID. So this ID from the regex can be extracted by the URL pattern API. So we can say the delete user route dot, I always forget what is this. So there's .test, .exec, and then there's I'm mixing it up with the other things. So in this case, we're gonna execute it, which is executing. Let's see if it shows here. We're going to be executing this URL pattern, matching against the URL that we're going to be giving it, and it's going to pull out the requisite parts. So for example, if we were looking, for example, like here's a documentation for an example of books and ID. We saw this in the routing videos. If you want more practice with this, definitely take a look at that. We can exec against that and pull it out as part of a regex match as part of that path name group, which is going to be pretty nice. And it even has its own, the name that we gave it, which is pretty cool. So I'm going to say we're going to execute it against our URL here. What we can then do is this is going to have the URL pattern result. And what we can do is we can say, so I'll just test this so you can see what this looks like. We're going to say user ID dot path name dot groups dot ID is what we want. Now this could technically be null, hence the optional chaining here. So that means that this could, if this is null, then just log out null. If it's not null, if it actually has a match, then actually go ahead and grab these properties and drill down to the ID. So let me save this and I'll open up my terminal here just so we can see that that works, and we'll try with and with an ID. We can't actually just put without an ID because in this case it's part of, it won't even come in here if there's no ID. So let's test if that works. So if we go back to our Insomnia, I expect to do /user/2. I'm going to be pulling out the /2 part here. So I should expect to see the number 2 being logged out here. Still a 404 because we're not really doing anything different. And indeed, we do get that number 2, which is quite nice. So we are getting, in this case, I think it's a string 2. So we should probably turn it into the number 2. But that is correctly being pulled out, which is nice. And again, this is all from the URL pattern API because this is the regex that it's looking for. And then this is the dynamic part of the URL, which is this part right here, the ID. Okay, now what we can probably then do is say, we need to look through this users.json file for the user with that ID and just delete it from that file. So we need to read in the file, grab all the users, loop through each user, and if we find the user that has that matching ID, then we can delete it from that array and save it back to the to this file without that object in there. So in this case, if I'm deleting 2, I expect this array basically to look like this after with that number 2 ID of banana, or ID of 2 and name of banana deleted from the file. So let's go ahead and read the file. So I'm going to say const users is equal to await deno.read text file, and we're going to be reading users.json here. And in this case, this is going to be actually a string. So I'm going to actually name this as, I guess, for now, I'll just call this users file. And I'm going to say const users is equal to json.parse of users file. We could do this in one line as we saw previously, but I'll just do it in 2 steps here. Now, users is going to be our list of users. We're going to loop through that to find out which one matches this ID and get rid of it. Now, there's a few ways to do this. We can do things like splice or slice. I always forget which one is which just does it in place. But we should probably, another easier way to think about this is we effectively want to filter this array and get rid of the one that has a matching ID. So I'll say const updated users is equal to users.filter, and we're going to take each user and we want to make sure that that user's ID does not match the, so we want to keep all the values where the ID is not equal to this. So we're saying where the user.id, we want to keep it if it doesn't match, and we want to get rid of it where it does match. So filter is going to take, this is an array method on in JavaScript, and we return true to keep the item. We return false to get rid of the item. So we want to make sure that we're getting rid of the item where it's equal to this and keeping the items where it's not equal to this. So we're going to say is not equal to I guess in this case we actually have to make this a number because it is a string. So let's just test that to make sure that that actually is the case. User ID, just like that. Okay, and I think in this case it's complaining for Deno because it doesn't know what a user is. So we should technically be making an interface for this. I think this is okay for now. I'm just going to let this run. And I'll show you how maybe we could create an interface if we did want to, just so we could get some nice type hints, and it would be a bit more helpful and correct way to do this because we are technically using TypeScript. So if I say const or console.log the updated users, I think that this is not going to work right away because this I believe is a string and we're using a strict equals here. We're not casting it. So let's see what happens. So if I open my terminal and I try to delete user number 2, by going to Insomnia, I'll send this off and I go back here. You can see that user number 2 is still in there, but let's see what happens if I change this into a number first. So I'm going to say, I actually realized as I was doing this too that we actually I messed this up right here. I shouldn't say we, this was definitely me. I messed this up here. When I console logged out the user ID, I actually grabbed it from the groupings and I forgot to do that here. So I'm actually testing this against the pattern result directly, which is not what we want to be doing. So this is actually not the user ID here. This is the matches, I guess. So your user ID, I'll say const user ID is equal to the matches dot path name dot groups, and then we want dot ID. Now this is the thing we want to turn into a number, just so that we can actually log this out. So let's see. Let me just console.log out this user ID just so you can see exactly what that is. And if I go back to Insomnia here, I'll send that off just to confirm that I'm not totally losing my mind here. I am logging out the number 2 here in this case. Notice a slight text difference with my terminal here. And in this case, since I did turn it into a number, now it's actually filtering correctly. This part is filtering correctly as well. So I just did that number calculation or conversion, I guess, casting up here instead. Also, I forgot to pull it out of the matches. I did that for the console log earlier, but I forgot to do it when I removed the console log. So we have to pull out, because this is the list of matches, and we pull out from the groups the matching ID right here. So I'm just going to go over this, since this might be a bit weird to kind of look at if you haven't seen the URL pattern API and some of the filterings that we've been doing. Is we're executing a regex. If you haven't seen regex, I have a video on regex in the JavaScript series on the URL with this pattern right here. And the details are kind of being handled with the grouping and everything of the natural regex construction by the URL pattern API. So what we're doing is we're grabbing the group and the ID out of that, and we're casting it to a number, because by default it's a string because it's a URL. So then what we can do is we can take that ID, in this case the number 2 right here, and we can loop through, once we read in the file of JSON for the users, we can loop through all of them for each user, make sure that it doesn't match the ID that we're looking for, and this has the effect of filtering out the user that we're not interested in. Now if we did want to get rid of this kind of user error right here, and this would be the correct thing to do, although ideally you'd want to do this in a separate file. I'll just show you how we would do that. We can create what's called an interface. In this case, I'll just call this a user interface, and I'll say each user has an ID, and in this case, if you think about it, the ID is a number and the name is a string. Okay, so we have ID is going to be a number, and the name is going to be a string. Okay, so that's kind of what it means to be a user in our system. And this is kind of using TypeScript's interface syntax to actually allow us to do some custom typing. And the way that this will help us is if we go take over here where our error is. If I scroll down here, you'll see that this is a user. Parameter user implicitly has an any type. if I do a colon here and I give it a user type, just like that, now you can see that the error goes away because if I do user dot something, you can see that now the only two things that the user can have is an ID and a name, and this would be the more correct way to actually do it. So just be aware that that's just a TypeScript syntax for interfaces. If you don't really want to do this, you can kind of safely ignore it. Notice that we did the same thing here. A request is of type request right here, which is coming from the actual web API for the request interface. Perfect. So that actually works. I'm just going to get rid of these console logs here. And we saw that that actually did log it out. I got rid of my terminal there as well, but that's our updated user. So now we want to write that back to the file. So I'm just going to split this up a little bit so you can kind of see the steps here. We're grabbing the ID, we're matching it, we're reading the text file, then we're grabbing the JSON version of it, and then filtering out the updated user. Now we're going to save that updated user back to the text file. So I'm going to say await deno.write text file, and we're going to write to users.json, and we're going to be writing the json.stringified version of the updated users. Okay, so we're going to take that list with that user now removed and save it back to the text file. And if that all works, then we can return a new response here. We should technically send back a 204 because we are not really sending back any data. So I'll just say a null response, but the status this time is not going to be a 404, it's going to be a 204. If I go to Chrome really quick, I'll just show you what I mean. I'll just go to HTTP status codes. And if we go to the MDM page for that, and I scroll down, once that loads up, you can see that the 400 range of status codes are the client, 200 range are the successful responses that we're interested in. The 400 range is the 404 that we were sending. So if I click on the 200 series there, it'll scroll me down here. 200 OK is fine. You can see that they kind of explain some use cases for 200. You can technically use a 204 for put and patch as well, but I'll show you here 204, no content. There is no content to send for this request, but the headers may be useful. The user agent may update its cache headers for this resource. So if I click on that, you can kind of see a little bit more of how that might work. And also the delete page, if you kind of go over to that, would be another resource that you could take a look at for how this might actually work. I'm surprised they don't have to delete on this page. They should probably update it. But that you can see that they do say that you can technically use this for a put request. Although it's probably not always necessary to send back the data that has been updated, but some APIs do like to do that, in which case it wouldn't be a 204 no content. You would put content in the body and it would be 200 instead. Okay, now so that works correctly. So hopefully that all works. So if I save this now, recall our users.json looks like this. If I send off a delete request to this API that I've built right now, and I'm trying to delete user 2, we should have number 2 gone from here. So if I go back to Insomnia, HTTP localhost 8000 delete request for user number 2, I send that off. I expect to get back a 204, and then I should go and see that file has been updated. So if I send that off, I do indeed get back a 204, which means that it was a successful response or a successful request, and I got the successful response back. If I go back to my user's JSON file, you can see now it has been updated to only have that singular user in there. That second user of banana is now gone. Okay, so we are not usually sending back the data because we've deleted the data, and the client kind of already expected that that's now gone, and it should no longer have a need for that user once it knows that it's been deleted. Now you can technically send the body back if, for example, that's part of the reason you need this type of API built. You can make that decision when you're designing these APIs. You can make any decisions you want and send back whatever you want with any type of status codes and mess around with all the put, patch, delete, and all that kind of stuff. But it really is up to you to keep it consistent and document it properly, so there is some consistency between the different routes, and it does make sense to the users of those routes. Kind of the consistent behavior is maintained. So there you have it. That's really just a delete request, and that's how it works. And you could do this for any type of route, for any type of resource, and it would generally follow this pattern where we have a resource we want to delete, we grab the information for it, we would make sure we're in that route, we would kind of grab that from the URL, we would grab the information from our database, in this case it's just a file of JSON data, we'd get rid of it. So that would be like if you're using relational, like SQL command or like object MongoDB command or something to get rid of it, you'd save that back to the database and you send back a 204. And that's the general flow for how you delete a user, although there are some caveats that I do want to get to wrap up this video. So if I switch back here, I want to go back to these considerations that I kind of hinted at the beginning. Imagine we do a delete request and we're deleting a user just like we saw with that example that we built out together. In this example here, we're saying, please delete user with the user ID of number 5. Okay, so here are some really important questions to keep in mind at the back of your mind when you're building these types of APIs, especially when it comes to something like delete requests. And we will look at some answers to these when we look at some of these topics shortly. Now, does a request body make sense? I kind of just went over that. We send back a 204 generally if it doesn't have something. If there is a body and the client does expect a body for whatever reason, then it might make sense to send back a 200 with like a whatever body type, like a JSON encoded body, for example, like you would with a post request. But that is really up to the designers and the specifications for the API that you're building. Again, as long as it's documented and it's clear the intentions of the API and it's consistent across the put, patch, delete, get, and all that kind of stuff post, that should be fine. Now, here's an important one. What about permissions to delete? Does it make sense for me to just be able to send out a delete request and delete a user by an ID? Probably not, right? Generally speaking, what you would want to happen is be able to delete your own user, for example. Like let's say I'm logged into some service, like for example, YouTube. If I'm logged into YouTube and I want to delete my account, I would probably be allowed to send a delete request to delete my own account with whatever my user ID is. But it wouldn't make sense for me to be able to delete someone else's account, right? That would be very kind of weird and very unfair. I shouldn't be able to delete other users or other resources for other users without having the permissions to do that because that's not my content, right? So we do have to be aware of that. In this case, we did not do that. Any user in this example that we just built can delete anything, which obviously we'd want to fix when we actually build this API for something like production purposes. But we do have to look at some other things we need to learn in order to handle stuff like that. So what are those things? Usually you see things like authentication and authorization. So we do have to keep in mind those concerns. We'll go over authentication and authorization separately in a future video after we look at cores probably. But that's usually one of the ways that we would use to make sure that we lock down an API to make sure that the permissions or the things that users can do are limited to whatever it is that needs to be limited to, so that they don't have kind of ramifications onto other types of content that might be not what we want to happen. What about deleting a whole resource or a collection? Like imagine if we had like a users plural collection and we allowed delete. That would imply that we could delete the entire users collection without an ID. So that would be a bit strange. Is it possible? Absolutely. You can code whatever you like. You can build that route out and make it do that exactly. Now, the only challenge with that is it's a bit dangerous, right? If you think about it, does that really make sense? What cases does that make sense? What cases does it not make sense? Does, for example, YouTube have a route to delete all the users? I would be skeptical. That sounds like it would be a recipe for disaster, because any type of security issue or loophole and someone finds a way to access that route, even by accident, and that happens, that would be a bit of a disaster. So generally those types of deleting everything operations are not exposed through an API, and you would have to do it kind of manually. You probably have to like log into the database and like have a special account and all that kind of stuff to do that kind of stuff, because it's very rare that you do need to delete a whole collection. But there are some exceptions. For example, if you have like a CMS like WordPress or some other kind of CMS platform, it might make sense to create and delete types in bulk. So it really depends on the use case that you are actually using. The last thing I do want to mention is the encoding types, such as the form, multi-part forms, and URL encoded. Does that make sense for a delete request? Now, you can build a delete request however you like, and of course you can accept form data, for example, just like any other type of request in the body. So it's really up to you. Again, it kind of comes back down to design and the expectations of the API and what it is you're actually looking for from the client and what the client is expecting from you as the server or the builder of this tool. So all these, as long as it's consistent, as long as it's clearly articulated and documented, and you keep those documents updated. If you do update things, that's all that really, really matters. But generally speaking, the flow that we saw together today in this video where I do a delete request to a specific endpoint with all the information in the URL is usually what you'll see, and it's most of the information you need to actually get that task done. So there you have it. That was a little bit shorter because it's definitely one of the quote unquote easier ones to consider once you've learned all the other ones like get, put, post, and patch. So hopefully this one made sense to you. If you did like this content, I'd love it if you could like the video and subscribe to the channel. As well, if you want to support the channel and these videos in the future, I do have a Patreon set up. I have YouTube membership set up and super thanks as well. If you want to contribute that way, that would be wonderful. What we're going to do in the next video together is go over CORS, so cross-origin resource sharing, which is definitely a topic that it trips up a lot of people when they first start doing web development, especially when they're doing things like front-end development. So we'll go over all of that and how it works with the browser, how it works in the context of the API, before we get into things like authentication and authorization. I can't wait to get to that. I will see you in that video.